Okay, this is volume and surface area of both cones and spheres, and I'll show you how to do a frustum as well. So there's four formulas. First of all, your cone, which is of that shape, okay, and the surface area, so the curved surface area of a cone, curved surface area is pi RL. R is the radius of the bottom of the cone, so in here is R. L is the slant height, so this height here, okay, and H in a cone is this height. So sometimes if you have H and O, you'll have to use Pythagoras theorem to get L, and if you have L and O and you need to find H, you have to use Pythagoras theorem to get H. So, and the volume of the cone is a third pi r squared H. Okay, so just say we've got a cone with a radius of 5. I'll put it in here. So you've got a cone, I'll do it in a different colour, with a radius of 5 and a height of 12. Okay, if we want to find the curved surface area, so the curved surface area is pi RL, but we don't know L. So we have to use our right angle triangle here, Pythagoras theorem, to find out L. L is the long side. So to get L, L squared is equal to 12 squared plus 5 squared. So L squared is equal to 12 squared is 144 plus 5 squared is 25 is 169. So that means L equals the square root of 169, which is 13. So L is 13. So the curved surface area is pi times 5 times 13, and that's, working it out, 65 pi, which is 204.2 to 1 decimal place centimetres squared. And also, if you're asked to find the volume of that cone, the volume is just equal to a third pi r squared H. So it's a third times pi times 5 squared times 12. And you can just do pi times 5 squared, so pi times 25 times 12, get that answer and divide by 3, or multiply by a third, same thing. And that gives you 314.2 centimetres cubed for volume to 1 decimal place. So that's a cone. Now a sphere. A sphere is just a 3D ball, and your radius comes from obviously the centre, okay? And the surface area, the surface area of the sphere, is 4 thirds pi r squared. Oh, sorry, 4 pi r squared. 4 thirds is the volume. 4 pi r squared. And the volume of the sphere is 4 thirds pi r cubed. Now, all these formulas are given to you. So all you have to do simply for the sphere is, if you had a radius, just say of 6. So the surface area is 4 times pi times 6 squared, and that's 36 times 4 times pi, which is 452.4 centimetres squared. And if you're asked to find the volume, it's just 4 thirds times pi times 6 cubed, which is 4 thirds times pi times 6 cubed, and that gives you 904.8 centimetres cubed. Simple as that. If you're given hemispheres, you just have to. So the surface area of a hemisphere, and there might be a trick in it. You might have to get the surface of all the on a hemisphere. So a hemisphere is a ball like that. This curved surface area is only half a sphere. So instead of using this, we use half it. So that's 2 pi r squared. But we also have to add on this surface on the top, because when you cut it, you get a circle, which is pi r squared. So that gives you 3 pi r squared. So adding them two together is 3 pi r squared. Okay? But if you're asked to find the volume of this hemisphere, it's just half of this. So it's 4 thirds pi r cubed and half that divided by 2. Okay? Frustrums. Frustrum is a cone with the top cut off it. So for example, if you've got a cone coming up and then you cut the top off it, so that top's missing. Okay? All you do to get the volume of a frustrum is get the volume of this whole cone, okay, using this radius down the bottom, and the full height with a third pi r squared h. Okay, and then you take away the volume of the top cone that's missing, which is this cone. So we'd use this radius, and this height, and you just take the two of them away. So third pi r squared h of the large cone minus a third pi r squared h of the small cone, and that will give you the area of the frustum, which is just this bit here. Okay, and that's what a frustum looks like. Top cut off it.